Hello, everyone, and welcome to another Microsoft Reactor session. Today, we're going to be talking Azure Static Web Apps. It's a new offering in Azure that's currently in preview. And I think I'm hoping that you see what I see is very cool. Gives us the ability to quickly stand up a CI/CD pipeline for like a Blazor WebAssembly with a C# API. So we're going to kind of walk through that, kind of see how to do that together. And I think when you get to the end, I think you'll be as impressed as I am. Very, very cool technology. Again, gives us the ability to, take a GitHub repository that contains a Blazor WebAssembly and a C# API, package it together, and push it to a PaaS offering in Azure with just a few clicks. And then it continues to monitor that repository, a branch of your configuration. And as pushes are made to that branch or pull requests are submitted for that branch, those updates get automatically pushed into Azure for immediate usage. So let's go ahead and get started. Great to have you here. Great to be here with you. And really excited to kind of walk through this material today. So just real quick, a little bit about the reactors. What are the reactors? Well, the reactors are an opportunity for us, you and me, us around the globe who are technologists, who are working to stay ahead of the technology curve. These give us an opportunity to collaborate. They give us an opportunity to connect. They give us an opportunity to learn from one another. So, we can meet through these virtual sessions, and hopefully at some point we'll be able to meet again in person, but we can meet during these virtual sessions and have an opportunity to, really learn from one another and see what's available in terms of new technologies and how, hopefully give us an opportunity to, learn from one another and push ourselves forward, stay ahead of the technology curve, leverage some hard work that others have done that maybe gives someone else an advance. So let's see, what are the main advantages? There's a question. So this is a great reference. I do want to call your attention to a couple of things here. This event is being recorded and will be posted to a Microsoft Reactor YouTube channel shortly after its completion. So definitely look for that. Secondarily, there is a Q&A area within the team's session that we're together on today. Make sure you take advantage of that. Please ask questions, post them. We have Maria, who is here monitoring that Q&A area. We'll publish those questions, and then if they make sense to sort of address contextually at the time, great. If maybe we push it a little bit until we get past a particular thing, a particular area that we're focusing on currently, great. But we will look to address as many and hopefully all of those questions as possible in during our time together. So the question that came in, which is great, what are the main advantages of hosting on Azure Static Web Apps versus Blob storage? Great question, right? Because Blob storage gives us the ability to host a static app there, right? Azure Static Web Apps allows us to package up a static web app like a Blazor WebAssembly and a C# API, and then push them together. And Azure will take care of all the necessary resources to keep them bundled and packaged together. And then the other benefit is as we, it monitors a branch in GitHub, and as changes are pushed into GitHub, there's an automated, and again, you could do this yourself, right? But with just a few clicks, it automatically includes a GitHub Actions workflow that will push those changes automatically into your live site. And, which we'll talk about, if you have a pull request that you have, that's been approved, it can automatically build a staging version of the site, right, that can run in parallel with your main version to allow you to verify and validate the changes before actually pushing it into mainline. And that's all included right out of the box, right as part of the offering. So Great question. Let's go ahead and dig a little bit more into, sort of the specific topic and why, I think we'll be able to answer that question some more as we go. Reactors, again, just real quick to wrap this up, all over the world, which is awesome, right? The opportunity to connect with people from a lot of different countries and who have a lot of different experiences just makes each one of our opportunities that much more rich. All right, so publish a Blazor WebAssembly on Azure Static Web Apps. That's what we're going to be talking. A little bit about me. Here, I don't have a beard. Obviously, on the camera I do. So this is a few years ago. But my name is Alan Sanders. I am a principal cloud architect, and excuse me, I have been in architecture, design, and development for about 25 years now. So I've had a chance to see a lot of things and learn a lot of things. I've been in some, large verticals like finance and insurance. I've worked for some small companies, done some consulting. My primary area of focus is Azure, but I have a chance to do some other things as well, which is awesome. But the one thing I want you to kind of know about me is my passion for learning. I'm very passionate about learning. I love to learn. There's so much to learn. There's always going to be something new to learn in this industry, in this field. That's why I love it. So I'm passionate about learning my own, but I'm also passionate about others learning as well. So I'm really hoping that you get a lot of really good information out of this as we proceed today. And again, draw your attention again to the Q&A. Make sure that you post questions if you have them, and we will address as we go. So let's look at our agenda. So what are we building? All right, let's build it. We'll do a knowledge check and then summary. I don't have much in the way of slides because I really want to be able to get to the code and the process so that we can walk through it together. So what are we building? This is what we're building. An Azure Static Web App monitors a GitHub branch of your configuration. All right, and then on push to that branch or pull request with that branch for the repository, it automatically triggers a GitHub action workflow that then packages and pushes the updates to Azure. And the nice thing, again, about it, one of those advantages is it includes a facility to automatically bundle your static content and an API. And the API is going to be an Azure function. So fully platform as a service, managed services, native services that we're deploying to. And the facility just really, makes that easier to do altogether. Again, could you do this without Azure Static Web Apps? Absolutely. But this kind of takes those things that we always do in these situations and makes them that much easier. They just builds them into the offering so that as we set it up, it's available. Okay. So this is what we're going to be building, right? We're going to be walking through this and you're going to have a chance to build it alongside me. And I would strongly recommend that you do. At the end, I will provide some additional links for follow-up. Definitely take a look at those to, again, take the opportunity to expand your understanding and enrich your learning relative to some of these topics and technologies. But we're going to have a chance right now, actually, to do that. So let's build it. Let me post this link to our chat. So I'm going to make an announcement. Feel free to hit that link and follow along as we go. Okay, when you hit that link, it should take you to this page. So what we're going to do, we're going to clone and run an existing Blazor Web app locally. Then we're going to leverage an API that's included. And then we're going to publish both of those things to Azure, but we're going to publish them to Azure Static Web Apps. So what we're looking for in terms of prerequisites here, basic knowledge of web concepts, C#.NET experience, at least at a beginner level. We're not going to really dig too deep into the C#, but we will look at it. You need a GitHub account, and then Visual Studio 2019 or newer. We want to have the Azure and the ASP.NET and web development workflows installed. So let's go ahead and get going. So introduction wise, again, I'm not going to, go through all of this, but I do want to just draw your attention to it. So technology that's currently in preview. But what this does is it gives us the ability, as I said, to package up a static app like a Blazor WebAssembly and a API together and push those into a combined Azure resource. And what it will do, because it's static, it just like we can do with storage, blob storage, is we can make these apps available closest, make them globally available, right? They will be globally available. They will manage, scale elastically, and they will have hosted options closer to different folks who might be utilizing or accessing. All, technologies that the cloud gives us, geo redundancy, availability, scalability, and then also, locality or keeping things regional. All of that stuff, is part of the cloud, but we also get it here within the Azure Static Web App. So one of the things that's kind of cool about this is it includes free SSL certificates, which are automatically renewed. And again, that's part of many offerings within Azure, but it's just one of those other key benefits that comes, away from leveraging this particular offering. So this is what we're going to be building. Not a super, complicated interface, but the point is not necessarily the code or the interface. The point is more the deployment and how it integrates and how we can automate. So this is just going to give us a way to sort of, manage via CRUD, create, retrieve, update, and delete a shopping list. Okay. So we'll have all of those features and functions available to us. Let's go ahead and begin. So the first thing we're going to want to do is create a repository. And so we can navigate to there's a GitHub template repository that we can use as a starting point. So I'm going to open that up. And then basically here's the repository that we're creating from. I'm going to create one in my account, and I'll call it my static Blazor app. Again, please feel free to follow along with me here. We can keep it public for now. Let me make this a little bigger. There. We can make this one, that's a little bigger too, good. We can keep it public for now. We'll go ahead and create that repository from the template. Should just take a few seconds here. And now we have, a new repository within our GitHub account. I'm going to grab the clone link, the URL for cloning. I'm going to copy that. And then I'm going to open Visual Studio 2019. And then right here from the homepage, I can choose to clone this repository and then, give it a path of your choosing on your local system to which you want that to, associate with. And then I can click clone. What you should end up with is a solution that has 3 projects in it. One is an API, it's a C# API, which is really built atop Azure Functions. One is a client app, which is going to be a Blazor WebAssembly. And then one is this data is really just intended to represent our data layer or our model, right? Pretty simplistic model relative to a shopping list, ID, name, description, and quantity. So make sure that the client project is set as startup, and right click that and say set as startup if it's not already set as startup, and then we can just run it. And so here's our app, right? That is running locally, not really doing much yet. There's no get route for the API. The retrieve part of CRUD is not included, right? There's a create, an update, and a delete that's already included, and it's built around just an in-memory collection. That doesn't really connect to a database. Obviously, you certainly could and would connect your API to a real database, but this is just using an in-memory collection for demonstration purposes. But right now, it's not displaying any data because we don't have a get operation available on the API. But that gives you sort of a sense of what we're doing. If you can get here and it runs, then you've been able to successfully clone, and we can kind of move on to the next step. So I'm going to close this out for now. I'm going to come back over here. That's basically what we just walked through. If we go to the next unit in this Microsoft, and Microsoft Learn, by the way, I think is an excellent platform. If you've not used it before, I highly recommend it. It does a great job, in my opinion, of combining information about a particular technology, helpful links, detail with hands-on exercises that you can work your way through, that I think really helps to reinforce the material that is being covered. So highly recommend it. It's kind of cool. You can earn experience points, and with those points, you can earn badges, and then that's kind of fun. But I think it's really just awesome because if you click all the way back here to learn, you can see that there are tons of learning paths that include many different types of technologies. Okay, so we're going to plan our Azure Static Web App, and again, I'm not going to read through this. I'm just going to sort of highlight it. I would definitely recommend you go back and read through it, but I would rather give you some sort of overview commentary and then let us get to actually doing it. So we're going to have a static web app, and in a static web app, before we deploy it, it has to be built, right? Because it's a Blazor, it's going to be built out as a Blazor WebAssembly. We need to build, and once we build, then we have static assets that can be pushed and hosted in Azure. Could be hosted in Blob storage, as Mina suggested in the Q&A, but we're going to host it in an Azure Static Web App. So there's going to be an app location, which is client. This is going to be required. There'll be an artifact location, probably www root, which is basically where your build artifacts will land, right? And then there's an API location that's not required. But the cool thing about this offering is you can easily connect them and push them together and have the Azure Static Web App manage the Azure resources that are needed. So we're going to, set up that Azure Static Web App in just a minute here. And when we set it up, we'll have an opportunity to, in the portal, Azure Portal, connect it to a branch of a GitHub repo that we want to have monitored. And then as changes occur, right, what that's going to do is create a GitHub action workflow that as changes occur on that branch, it will automatically deploy our application, build it and deploy it. Okay, the API, as I said, is Azure Functions, but we'll drill into that a little bit as we go. And Azure Functions, by the way, if you've not had experience with those before, Azure Functions are a serverless technology within Azure that enables you to, host code in the cloud So, you really don't have to think about servers or infrastructure. You just are able to push your code to the cloud, and then all of the infrastructure management and scaling is taken care of for you automatically as part of the deployment into the cloud. So let's go ahead and create. So if you have a Azure Portal account with some credits, great. This lab, the cool thing about this lab is it gives you the ability to use a sandbox. So if you don't have an Azure account, you can use this temporary sandbox so that you don't incur any charges, which is, very good. So what you'll want to do is click this button up at the top here, sign in to activate the sandbox. I've got two-factor authentication on, so I need to input this after I can read it. Okay, and we can see that it's going to be, I think you're allowed 10 sandboxes within a 4-hour period, and or within a day rather, and you get 4 hours with each sandbox. You get 4 hours worth of time. So there's a question posted, why should I use GitHub instead of Azure DevOps? You could use Azure DevOps, okay, but what we're going to show is the fact that built into the offering is a connection to GitHub, right? That the ability to sort of connect directly to GitHub and leverage GitHub action workflows to push. So as with anything, there are multiple ways to do it, but the reason we're focusing on GitHub here is because of its direct integration into the offering. And so we're looking for an opportunity to kind of show how this, pardon me, how this just facilitates that, right? With just a few clicks, you can do that. Now, with Azure DevOps, certainly you could, as I said, with some of the other, building it in a blob storage, for example, we've done that, right? We've built those up. We know how to do that. It's very, very common to do that. But the cool thing about this is it handles all of the connecting the plumbing for you across the different pieces that are in play. So you might find that Azure DevOps is a better choice for you, but in this particular case, we want to give you a chance to see the GitHub integration and maybe determine if this is the right route for your app. Okay, so once this happens, once this runs through, you should end up with a sandbox activated, some amount of time remaining. So after we do that, we click this link to sign into the Azure Portal. Now, what you want to do is make sure you sign in with the same account that you use to activate the sandbox. And if you do that, what you should see up here is that the subscription you're working within is the Microsoft Learn sandbox. So that's key, right? You activate the sandbox with an account, you then sign into the portal with that same account, and it should provide you access to this Microsoft Learn sandbox, which allows us to test these technologies without incurring charges. Now, the Learn sandbox is only for learning experiences, right? They're not intended to host any workloads of any reality. It's more for our learning purposes only. I want to make sure that's clear. So let's go ahead and create a resource. We'll type in static web app. You see it's in preview. We're going to create it. And so the concierge subscription should be selected. The Learn, and I misspoke, this is not a Microsoft Learn Sandbox subscription, this is a tenant. Here's the subscription, the concierge subscription that we're actually attaching to within that tenant. We can give it our app a name. I'm going to call it Blazor WebAssembly. Pick the region that is closest to you. Mine is going to be East US 2. By the way, I'm in Columbus, Ohio. And then this is sort of that last question from, let's see, it was Jason. Here's that GitHub integration I was talking about, right? Now, I don't have to do this, right? I could do it a different way, but we're going to sort of show you this as at least maybe another tool in the toolbox. So if I sign in with GitHub, it's going to ask me to authorize access to my repositories, to my account from Azure App Service Static Web Apps. When I click that, so now it's going to be able to, associate the rest of these configurations with my GitHub account. So I can choose my organization, which in this case is just my account. The repository I want to use is this My Static Blazor app. And then the branch I'm going to monitor is, and hopefully you folks are able to see that. Let me make that a little bigger. The branch I'm going to monitor is main. When I choose that, you'll notice that there are now some additional options, right? So this gives us the opportunity, based on the type of application, right? This will build the GitHub Actions workflow accordingly. So we're going to be doing Blazor in this in this case. And when we do that, it's going to default the app location to client, the API location to API, and our output location to www root. Now, in our particular case, if we go back here to Visual Studio, you can see we have API, client, and www root. So we are good to go here with these settings. These are the settings that we would use. I'm going to review and create. And then finally create. Should just take a few seconds to spin up that deployment. Let's go to that resource. And here is our static web app. Now, what's interesting about this, in my opinion, is if we go over here to our GitHub repository, let me refresh this. And now you see that it has automatically added this YAML file for us. This is a GitHub Actions workflow. Additionally, if we go to the Actions tab here at the top, you can see that it is already running the build and deploy for our application automatically. So you can go to Actions to see any workflows, GitHub Action workflows that are running. We drill into the currently executing one, and then we can drill into a particular job within that workflow to see its status. And this can take a couple of minutes to run. So we're going to let that run and kind of come back here and look at the, while that's running, we'll go back to code. Oops. And we'll look at our new YAML file real quick. So if you've had any experience with GitHub Actions, GitHub Action workflows, I have a link to provide you at the end for follow-up review and learning if you want. But, it will trigger. There'll be some set of triggers that dictate when this runs. And then there will be jobs that execute, right? And the jobs can be conditional with ifs here in terms of what type of activity is happening. It's gonna specify, the job's gonna specify a host that it runs on, in this case, Ubuntu latest. And then there are gonna be a set of steps with specific actions. And these actions exist within the GitHub GitHub Action Marketplace, or you can create your own. You can also just run things like, for example, npm install and npm test. So there was a question here Jason had. Good question. What's the difference between an app service, which I usually use, and an Azure Static Web App? So the app service, they're both PaaS services, right? Managed services. They can both be used to host, web workloads, right? But the static web app is often a good choice for something that is more static. The app service is good for applications that are maybe more dynamic in nature, that are going to be generated. They're going to have components that execute or run on the server as a web app. Whereas with the Azure Static Web App, what we're doing is spinning up a Blazor WebAssembly that could run in the browser, right? And so depending on the type of workload, if it's a heavier workload, a heavier web workload, then yeah, you would probably use Azure App Service. But for like a static workload like this, and it's not the only type of workload supported with Azure Static Web Apps, but those sort of static assets that we need to serve globally and at scale, we can do that in Azure App Service, but that might be a lot heavier than we need. Azure Static Web App gives us just what we need to support that, sort of maybe less intense web workload. So there are going to be, is one cheaper than the other? I honestly don't know what the pricing is yet on the Azure Static Web App since it's in preview. My guess would be that it would be cheaper, especially for those workloads that are less intense, because you don't need as much in the way of additional capability. But I can't really speak to that definitively because with it being in preview, I don't know what the costing is going to be. I'm just speculating, or my gut says it was probably, static web apps would be cheaper. Now you're not going to be able to do as much with a static web app probably, but it's kind of right tool for the right job. Do Azure Static Web Apps provide caching mechanisms out of the box for static assets, images, JS, CSS, etc.? I believe they do, right? And they allow us to, that's one of the advantages and benefits of a static, deployment is the caching. They tend to serve faster, right? They tend to be smaller, and then the caching that comes along with that is included. Okay. Great questions. I'm going to keep moving forward, but keep the questions coming. They're awesome. I love them. Here you see a job that's going to stand up that Azure Static Web App, and here's the configuration for that, right? Now, this was just, put in here automatically for me when I configured the resource in the Azure Portal, but it basically reflects the same settings we used from the dropdowns or the text entries that we saw in the portal. Now, if you were to edit this workflow, we're not going to edit it, but you can see here, there's a bunch of additional actions out of the marketplace that you could leverage and include, not just specific to static web apps, Azure Static Web Apps, but any GitHub Actions workflow you might have. These actions are available for you to pull in and utilize. So let's go over here back to our actions, and we see that it has succeeded. Okay, our build and deploy succeeded. If we go to our portal, now we should be able to hit this link and see our website hosted in Azure, right? So instead of running locally, we're running within Azure. So, all we had to do was set up the resource, attach it to monitor that branch. When that checked things in, including a GitHub Actions workflow, that automatically kicked off this build and deploy of our application to Azure. All right, so let's keep moving. Let's talk about fallback routes. Now, one of the things that is happening here, and so this gives us a chance to sort of look at fallback routes. Here in the browser, I'm going to /products. If I hit Control F5, it's going to come back with a 404 not found. Why? Because it is trying to serve a page called products. We don't have a fallback route in place that if we don't recognize the page that we're trying to hit, that we can default to something instead. And what we're going to default to is index.html, which will allow us to always come back to our products view. All right, if I get rid of this, index.html is going to be our default. That's great. If I refresh, it's going to give me a 404 because it's trying to navigate to a page called products. So let's fix that. We continue here. Let's go back over to Visual Studio. I'm going to, under the Get Changes tab, I'm going to pull the latest. And when we do that, if I open the solution, I right click and open the solution in File Explorer, you'll see that we now have this GitHub workflows. So we've pulled in the latest version of the code. And now what we're going to do is add a routes.json. So this is just going to be a JSON file. The name we're going to give it by convention is routes.json. And then we're going to, rather than me type this in, I'm just going to copy it and paste it in the interest of time, but we'll talk through what it's doing here. So this collection of routes gives you the ability to specify routing rules. So if you've ever done something like Angular, with Angular routing, where you can, specify based on a path or route where the application should go. And one of the things that you can do either in Angular or, in Blazor here in this app is specify that if we don't recognize the route that was requested, we can fall back to something by default, like this index.html, and we can give a 200 status code. So this just gives us a way to, if for some reason something is requested that we don't recognize, this gives us a way to manage that so that we don't end up with an error. Right now, you can have other routes of more specific as well. This is a very, very general route, right? This is going to match anything. If you have additional routes that you need to specify, the evaluation of the route is going to start from the top and go down. So any more specific routes need to appear in the collection before this one. This really should be the last route in your collection because it's going to match everything, right? So if we have something more specific we want to handle, that would go above it. And then we could kind of finish off with this to match, anything that's not recognized. So I'm going to save that. And then I'm over here in Git. I'm going to stage that and give it a comment, add routes.json, and then I'm going to commit staged and push. Okay, so if we go back over here to GitHub and we click actions again, we'll see that there is a new execution, right? All I did was push code to my branch. Because of that, there's now a new execution of our GitHub Actions workflow that is has been initiated just automatically, right? It's built into the GitHub Actions workflow technology, and it is linked with the Azure Static Web Apps. And the Azure Static Web App piece gives us the ability to package up this client and API together and push them, for example, into the Static Web App and Azure Functions. And all that's just sort of happening because I checked in that one file, or I pushed that one file change. So this is going to take a minute to, excuse me, a few minutes to run through. So let's come back here and, let's go ahead and start talking about the API. And we'll come back and check the progress of our current build shortly. So the API is going to be the thing that interacts with or integrates with our database or our data source. Now, in this particular case, our data source is just an in-memory collection, but obviously it could be, a SQL Server database or a Cosmos DB or Mongo. So we're going to have here an API that supports CRUD, create, retrieve, update, and delete operations. And the way we do that in an API is we use a get action. We provide a get method, right? Get method handler for HTTP that'll retrieve all of our products, a post that is typically used to add a new one, a put that is typically used to update an existing one, and then a delete that is used to delete an existing item or product in this case, right? So these API endpoints will be exposed and available for us to use. They're going to be exposed as Azure Functions, okay? And that's going to be built in C# right in our solution. And then when we check that in, the GitHub Actions workflow is able to package the app and that API up together and deploy them together and handle the necessary backend cloud resources for us. So let me see how we're doing over here. Okay, so that completed, right? Our latest add routes.json build and deploy job completed. And we can kind of see that now if we go over here and hit Control F5. It now no longer gives us that 404 error, right? And this is on our live site, right? We didn't deploy anything; it just happened automatically for us because of the way that this is configured and set up. Okay. So let's go ahead and look at the existing Azure Functions app that is in place, and let's add a get operation to accommodate retrieval of our product data. And really what we should do and what we're going to do to help us sort of, reflect this is we're going to create a branch. All right. And we can kind of see how Azure Static Web Apps supports on approve of a pull request, supports deployment to a separate staging site that you can leverage to verify your changes before they get merged. So here I'm going to go into my code in my branch. In my repository. I'll click this and say, I'll call it build-API. And I can just click this create branch right here. So we're now on the build-API branch. If I come back here into Visual Studio, this button, so right now if I look under my remotes, it doesn't show up. I can click this button, which initiates a get fetch. And after doing that, under remotes, I should now see my build-API. So let me check that out. Okay, and here's where we will start to make some API modifications. So if we look at the API, we have a product data class, which sort of acts as our repository, right? We've got some repository actions defined here, and then we've got an in-memory data store with some operations for maintaining data or retrieving data. Okay, it uses a get random int to just generate a random ID. If this was a database, obviously we'd probably use some sort of identity or auto increment feature so that as we add a new item to the database, it automatically generates an internal ID for it. But because this is in memory, we're just using a random number. And then we have Azure Functions for also the startup.cs. If you've ever done any ASP.NET Core development, you might recognize this. This is our dependency injection mechanism, right? So this gives us the ability to automatically inject anywhere we see iProduct data, an instance of product data. And that just allows us to follow good practice of coding to abstractions instead of concretions, right? It enables looser coupling in our applications. So here in the products post function, you can see it's an Azure function. It's going to be you can see how it's going to be triggered on an HTTP post to the route products. Here's the request and the log. There's a bug here that I'm going to talk about shortly, but this is going to execute the operations on our repository to add a new product. This one is a put, and you can see here the injection of that iProduct data interface that the dependency injection mechanism handles automatically. This is going to do our update. This is going to do our delete. What we don't have is a get. So let's add that. I'm going to right click here and choose to add a new Azure function. And I'm going to give it the name products get.cs. Now it's going to ask us what type of Azure function are we interested, or what's the trigger, what type of trigger is going to be used to initiate this function. We're going to use HTTP because we're going to want to respond to an HTTP GET. And then authorization, for this case, we're going to use anonymous. Obviously, you would have security in place separately and a more robust sort of approach than what we're doing here. But for demonstration purposes, we're going to use anonymous. My screen is doing some weird things, so I gotta. Sorry. So you choose HTTP trigger, anonymous for your authorization level, and then click. There should be an add button showing up, and it's going to generate this sort of shell of an Azure function for you. Right now, it's set up to be triggered on HTTP anonymously. Currently, it shows it supports GET and POST. We're only going to want it to support GET. And right now, the route is null, which means it's going to use this as the route. Well, we don't want to use this as the route. We want to stay consistent, so we can change this to products and then code our function logic. Now, right now, it just displays a status message. In the exercise here, it gives us the code. And again, rather than you watch me type it, I'm going to copy and paste, but we'll discuss about, we'll talk about what it's doing. So what it's doing is injecting our iProduct data dependency automatically. And then within this get request to products, we can execute a call to get products and return that set of products accordingly. Right? That's all this is going to do. This Azure function is going to get all of our products and return them on the response. Now, if I were to try to run this locally, the app and the client are going to be running on different ports. And so I would get a CORS or cross-origin resource sharing error within my execution locally. So there are ways for us to do that, to fix that, right? So I'm going to copy this. Actually, before I copy that, let me go here. In my API under properties, I'm going to add a new item. We'll go with JSON file. And we'll call it launch things.json. And then what I can do is I'm going to grab this and paste it here. And what this does is this allows me to handle CORS locally, right? When I start this up locally, this will enable CORS for any and all. This is wide open, right? So we again, wouldn't want to do this. It's totally wide open for any and all origins and types and methods. We would definitely want to restrict that, right? We want to follow the principle of least privilege. But for our demonstration purposes, we're just going to sort of open this up. And when I do that, then I now should be able to, oh, sorry, I started, but let me stop this. Before I start it, what I now need to do to run it locally is I actually need to right-click the solution and set up multiple startup projects. I now need on startup, right, locally, I need both the API to start and I need the client to start. So let me apply that. And now when I run it, what I should see is this window, which is showing us interaction with the function, the Azure Functions, which is like an emulator, a local emulator. And then here's my data, right? Here's my my product data: strawberries, sliced bread, and apples. Okay, so that's great. I can do things like edit this, bag of 10 fresh Macintosh apples. That updated, great. I can delete one, and we can watch here how this is executing the various actions or functions. Now, when I add, let me make this oranges, enable oranges. It'll be a description tub of oranges, and we'll do 3 of them. So I'm going to save this. Where's my oranges? Well, if you look here, you see that we got an error. We received an error on the post. It's because there's a bug right now in this repository. If you go to so we're receiving a note: hi, unable to follow, no subscriptions. You do not have any Azure subscriptions in the Microsoft Learn Sandbox directory. Click here to switch to another directory. Make sure that you are logging in with both the account, the same account that you activate the sandbox in. Make sure you log in with that same account to the portal. It should work if you do that. I apologize if it's not working for some of you. Again, this will be recorded. You'll have this that you can kind of walk through again after the fact. So my apologies. If you are logging into the portal with the same account you used to activate the sandbox and it's not working, look for an opportunity to kind of walk through and review after the fact. All right, so this particular bug that we're seeing is, pardon me, in the post, you can see here that when it goes to add a product, right, when it goes to run this function, instead of calling add, it is calling update. So what update is going to do, update is going to try and look for, update's going to try and look for an existing item in the collection with that ID. Well, it's obviously not going to find it. What we need in the post module instead is add product. Okay, so if we rerun locally after we make that change, close this out. Now I should be able to add my tub of oranges, 10 of them, and it shows up. Okay, so just kind of keep that in mind. Let's go ahead and close this out and look at what we need to do to push this now in whole up to Azure. So as I said, that GitHub action that's defined within our GitHub workflow is really the secret sauce here that is going to push those two things, the client and the API, together as a unified resource up into Azure, right? So that we don't have to do anything extra other than stand up an Azure Static Web Apps resource. That's what this action is, what's going to do that. So to trigger it, one of the ways that we could push this, push something into main, that would trigger it. But in this particular case, what we're going to do is submit a pull request. Okay, so let me go back to Visual Studio. I'll close all of these files. And then if I go to Git, I'm going to check and Git changes. I'm going to check in stage all of my changes. Update with API. And I'm going to commit staged and push. Now that's going to my build API branch. On that push, up under actions, you'll notice that we have not initiated another run. Why? Because this particular Azure Static Web App is set to monitor the main branch. Okay, so just by pushing, it didn't, because we pushed to a different branch, it didn't initiate. But the way, since we have it configured as such, we can create a pull request that allows us to merge build API into main. I'm going to create that pull request. Before I merge it, what I want to do is actually check the updates, but I'd like to check them in a separate staging area rather than in the main line. I'd like to be able to keep my live site running and then check my changes without necessarily jeopardizing my live site. So that's going to take a couple of minutes to run through. If we go over here to actions, we see our update with API. That's building and deploying our API, right? But it spun up because we created a pull request against the main branch, the branch that we're monitoring. So while that's taking a couple of minutes, this is really the last step. So let's go ahead and look at the knowledge check while we're sort of waiting for that to spin up. So knowledge check. When you make changes to your app, how do you publish an update to Azure Static Web Apps? Do you delete it and recreate it? Do you push commits to the watched branch or create a pull request? Create a new GitHub Actions workflow, or create and push a new branch to your Git repository? Well, the answer to this one is push commits to the watched branch or create a pull request to the watched branch. We saw that, right? As we pushed changes to main, or when we created a pull request, that initiated our, a new deployment, a new update, a new publish of an update. How do you view the progress of building and redeploying? Do you go to the production URL of your app? Do you go to your resource in the Azure Portal and view the configuration? Do you push your commits to your watched branch? Or do you go to the repository and navigate to the actions menu? Well, we've seen that the actions menu in our repository gives us a chance to watch and monitor what's happening with that build. How do you configure your app so that when you navigate to /about in the browser, that it serves the root index.html file? Well, for this one, we said we're going to need a routes.json for fallback routes, right? There's two of those here, routes.json that does a wildcard route to index, or routes.json that does an index route to index. Well, there are multiple ways you could do this, but for the options that we have available to us, our choice would be this one. Oh, sorry, not that one, this one. Okay. And then lastly, how do you tell Azure Static Web Apps that you changed where your API is located? In the GitHub Actions workflow, we saw, this is completed, by the way, in the GitHub Actions workflow, we saw that configuration here within the action. So back to this question, this is where we're going to configure that. Let's check our answers. All right, we got them all right. Now, before we finish up with our summary, let's come back here and now look at our pull request. If we open this pull request, here's the thing of note. Right here, it automatically generated a stage site for me. This is a site separate from my live site that has everything about the application in it, just by approving that pull request. So I can approve the pull request, have it deployed to a stage site, and then review and verify that everything works up in Azure as expected. Okay, so I can delete things. I can add things. And then I can edit them. All right. So all in Azure, but this is in a separate parallel stage site that allows me to verify and validate my changes before I push to mainline. Now, if I like this, everything's good, then what I can do is go back to GitHub. I can go to my pull request, and then I can open it and merge it. When I confirm that merge, if I can delete the branch now. If I go up here to actions, what you're going to see is 2 runs configured. One is going to be configured against the build API, which does this close pull request job actions. And one is going to be the actual merge and build of the main site. So it's merging my changes in and automatically pushing those in a true CI/CD fashion up to my live site. Okay, so couple of things to sort of wrap up with here. So what did we cover? We covered Azure Static Web Apps, publishing a Blazor WebAssembly with a C# API, and then automated deployment using GitHub Action workflows. Couple of things that you might find interesting to follow up on. One is, let me just copy some links here. Just to reiterate, here is the link to this topic that we've been, and Moria, I see, has mentioned, and thanks, Moria, for that. I forgot. There's a survey that you're going to want to execute. So Moria has provided the link. Please fill out that survey. That provides very, very helpful information to us about these events and what kinds of things you'd like to learn and cover. But please just take a minute or two to fill that out. That's very, very helpful, and really it has a lot of benefit for us. A couple of more links and then we'll be done. Here is a link for learning GitHub Actions. Here is a link to the documentation of Azure Static Web Apps. And finally, here is a link on Blazor itself, on information about Blazor itself. So thanks very much for your time. It was awesome being here with you. If anyone has any final questions, please feel free to ask them. Please take, just like I said, a minute or two to fill out that survey if you would. Other than that, it's been a true pleasure being with you. I hope you got a lot out of this. I had a lot of fun learning this myself, and look forward to being able to leverage it and use it going forward. That's it. Thanks very much for your time. Oh, wait, we might have one question. Hold on. Oh, thank you. Good deal. All right, awesome. Well, great opportunity to be with you. You folks have a great rest of your day. See ya.